Yes, so based on this first five properties, we will take few examples and after that we will move to the next property. Okay, so let us take, let's say, okay, let x of t and x of j omega form Fourier transform pair. Okay, form CTFT pair. Okay, question is find the CTFT of the following signals. Okay, of the following signals. All these following examples are based on the first five properties we have seen. Find the CTFT of the following signals. Okay, so first one, let us call that to be x1 of t, which is equal to x of 2t plus 3. Okay, so if x of t has x of j omega as the Fourier transform, then what is the Fourier transform of the new signal, which is x of 2t plus 3. Okay, so let us do this step by step. So how do you plot this signal here? Hint is, how do you plot this signal? So you plot this signal using precedence rule. You remember that what is the first step? We have to shift the signal and then time scale the signal. So let us, even in Fourier transform also we have to do the same thing. So let us define our new signal as x11 of t, which is equal to x of t plus 3. It is just shifted signal. Okay, so this fellow will have what as Fourier transform here? This fellow will have x11 of j omega as the Fourier transform, which is equal to x of j omega multiplied with e power j3 omega y. It is time shifting property. X of t plus t naught will have x of j omega multiplied with e power j3 omega as the Fourier transform. Okay, so we just got for the shifted signal. Now we want for time scaling. So let me call that as x12 of t, which is equal to x11 of 2t. Okay, so means what? Wherever there is t in x11 of t, replace with 2t. So you will get what? X of 2t plus 3. Correct, but we know that this is our original signal x1 of t. Okay, so if you find Fourier transform of x11 of 2t, that is same as Fourier transform of x1 of t. So which property we have to use here? We have to use time scaling property. So what will be the Fourier transform? That would be x11 of, sorry, that should be x12 of t will have x12 of j omega, which is equal to how much? X11 of 2t will have 1 by 2 times x11 of j omega by 2 as the Fourier transform. Why? Time scaling property, right? So x11 of at will have 1 by mod a x11 of j omega by a, but a is how much? 2 for us. Okay, so that should be equal to how much? 1 by 2 times, what is x11 of j omega here? This thing. So in this, what should we do? We should replace omega with omega by 2. So you will get 1 by 2 times x of, wherever there is omega, replace with omega by 2. X of j omega by 2 e power j times 3 into omega is there, that should be replaced with omega by 2. So that should be the Fourier transform x12 of j omega. But we know that x12 of t is same as x1 of t, and hence x12 of j omega should be equal to our x1 of j omega. So in that way, what is the Fourier transform of x of 2t plus 3 here? That is 1 by 2 times x of j omega by 2 multiplied with e power j 3 omega by 2. So it is always best to solve the problem by using the methodology of divide and conquer. So what do I mean by that? First you have to time shift and then do the time scaling. So we'll take one more example so that that is clear for you. Second example, let us take x2 of t to be equal to, let's say, x of minus t by 3 minus 4. Okay, so we want to find the Fourier transform of this signal, which is x2 of j omega. So we have to find out this fellow. Okay, again, how many properties involved? Time shifting, time scaling, and time reversal. So let us use all the three properties, but we have to use which rule? Precedence rule, because what is the how many shifts, how many steps are involved? Time shifting is involved, time scaling is involved, and time reversal is also involved. Okay, so let us define our first signal as shifted version of x of t, that is x of t minus 4. Okay, what is this fellow's Fourier transform? That should be x21 of j omega. Which property here? That is time shifting. So you will get x of j omega multiplied with e power minus j4 omega. Correct? X of t minus t naught will have x of j omega multiplied with e power minus j omega t naught. T naught is 4 for us. Next, let us define new signal x22 of t, which is equal to x21 of t by 3. Okay, x21 of t is this, so wherever there is t, replace with t by 3. Note that finally we want this signal, but we are going in steps. So this should be equal to how much? x21 of t by 3, correct, which is equal to x of t by 3 minus 4. So this fellow will have what as Fourier transform? x22 of j omega, which is equal to x21 of t by 3. So what is this fellow's Fourier transform? Time scaling. So you'll get 1 by mod a x21 of j omega by a. Correct. So this would be equal to 3 times x21 of j3 omega. So that should be equal to x21 of j omega is this. X21 of j3 omega means wherever there is omega, replace with 3 omega. So we'll get 3 times x of j3 omega multiplied with e power minus j12 omega. So this is our x22 of j omega. So finally, let us define x23 of t, which is nothing but x22 of minus t. Correct. So wherever there is t next to 2 of t, replace with minus t. So what do you get? You get x of minus t by 3 minus 4. Okay, correct. So that is what we have got. x22 of t, x of t by 3 minus 4. So wherever there is t, you replace with t by 3. Wherever there is t, replace with minus t. You will get x of minus t by 3 minus 4. But this is our original signal, x2 of t. Okay, so let us write down what is Fourier transform of x23 of t. Correct. So what is x23 of t's Fourier transform? That should be x23 of j omega, but x23 of t is nothing but x22 of minus t. So this fellow should have x22 of minus omega as the Fourier transform by time reversal property. So this should be equal to how much here? x22 of j omega is this. Wherever there is omega, replace with minus omega. You will get 3 times x of minus j3 omega. Here also we have omega, and hence you will get e power j12 omega. But what is we know that x23 of t is same as x2 of t, and hence x23 of j omega should be equal to x2 of j omega. So x of minus t by 3 minus 4 will have 3 times x of minus j3 omega multiplied with e power j12 omega as the Fourier transform. Okay.